Hi everyone. Today we're going to continue our investigations on earth sciences. Before we get started with the investigation, I want to start off with a demo, and I want to ask you guys to watch carefully and, as always, think and see. Can you tell me what you think is happening? To get started, I'm going to start off with a little demo, but safety first. And please don't try this at home. Going to put on my safety glasses, and I have two balloons here. I'm going to take one balloon, and I have a fire source here, and I'm going to actually, let me put that away for now. I have a balloon here, and I'm going to put fire below the balloon, and in your mind make a guess what you think is going to happen. Popped it. Not the way I thought it would pop, but it popped pretty quickly, right? Let's try that with the next balloon. Is the balloon popping? It's not, right? What's going on here? Let's try it again. I'm holding the flame right under the balloon, but nothing's happening. What do you think is going on? Take a minute, make a guess, and we'll come and discuss this in just a minute. Any guesses? Let's try it again, just to be sure. I have one balloon, I'm going to put fire under it. Popped immediately, and I have another balloon that doesn't pop. To answer this question, we're going to do a little investigation, and then afterwards maybe you can think of why the second balloon did not pop. For this lab, you will need 2 plastic containers, 2 matching lids with a slit cut through them, 2 thermometers. You will also need a timer, water, soil or sand, and you will also need either heat from the sun or heat from a heat lamp. For this lab, you may not have all the materials at home. If you don't, and I'm pretty sure most of you don't, that's fine. You can just follow along and watch as I do it. I'm going to use a syringe. I'm going to use 2 thermometers. I have 2 clear containers with the lids with a slit. I also have a cup of soil, and I have a cup that I have marked the 100 milliliter line to. For today's lab, I'm going to fill my containers up with 2 different samples, 2 different earth samples. The earth samples I'm using today are water and soil. If you don't have soil, you can use sand as a replacement. What I'm first going to do is measure 100 milliliters of water into my first container using a syringe. My syringe measures up to 50. So I'm going to fill it up twice, and that will be exactly 100 milliliters. Then what I'm going to do is take my thermometer with the lid, place it on top of the container, making sure the thermometer is inserted into the water, With my second container, I'm going to fill it up with 100 milliliters of soil. Can I use a syringe to pull up soil, to pull up a solid? I can't. So what I've done here is I have measured what 100 milliliters of water would be, and I'm going to fill exactly that into my cup, because we want to have exactly the same amount. And I am going to put that inside and even it out, place my thermometer into the soil and place the cap on. Now remember, in this experiment, I'm changing one thing. In science, every good experiment, you can change one thing, and that is called the independent variable. The independent variable here is our earth materials. Now here are the written instructions for this lab if you want to do this at home. We will be checking the temperature of different earth materials every minute for 10 minutes in the sun, and every minute for 10 minutes in the shade. Now the independent variable is the factor that is intentionally changed. The factor that we are changing, the only thing that we are changing are the earth materials. On the next page, the dependent variable, that's the factor that changes as a result of the independent variable. The dependent variable depends on the independent variable, and that's what we are measuring today. And what we are measuring is the temperature. And below, you want to make a hypothesis. If the independent variable, if earth materials are heated by radiation from the sun, then the temperature of the water will increase. Will it increase faster than, slower than, or at the same rate as? You have to choose one of these. So do you think that the water temperature will increase faster than, slower than, or at the same rate as the temperature of the sand and soil? And after the radiation is turned off, the temperature of the water will decrease. Will it decrease faster than, slower than, at the same rate as the temperature of the sand and soil? Remember, this is a hypothesis. It is your best guess. It does not have to be correct. I'm going to start off by taking the temperature in the shade, the 0 time temperature in the shade of the soil. You'll see it's at 21 degrees, and the water is at 23 degrees. So make sure that you are recording the temperatures on your data sheet as well. And then I'm going to move it to the sun, and our time will start. Okay, I have both samples in the sun, and we are going to check the temperature for every minute in the soil and in the water and record it. "45 seconds, almost there." Okay, I'm gonna take a look. And it looks like the temperature is at 25 degrees for the soil. And it is at 25 degrees for the water as well. Now I have a little pen propping up my water because I want to make sure that my thermometer stays inserted. Let's do our 2 minutes. And we are at about 27 degrees for the soil. And we are at 25 for the water. We are at our 3 minutes. Let's check our temperature. We are at 30 degrees for the soil. And the water is at 25 degrees. Okay, I just quickly moved my samples so that we could get a better view of it. And we are at our 4 minutes in the soil. It is at 34 degrees. And the water is at 26 degrees. Already you should be noticing a pattern. You should be noticing one is heating up a little bit faster. Okay, let's do our 5-minute read. This one is at 35 degrees, that's the soil. And the water is at 27. Always making sure my thermometer is inserted, the bulb is in there, and we are at 6 minutes. Let's check. To see. It looks like we're still at 35 for the soil, and the water is still at 27. We have 4 more reads. We are at the 7-minute mark. And it looks like the soil is at a little over 35. I'll say 35 still. And the water is at maybe 28. Okay, we are ready for the 8 minutes. Now this soil has risen even higher. It's about 37 degrees. And the water is at 28. I have 2 more readings, the 9-minute and the 10-minute. And then I'm going to quickly transition into the shade. And now we're going to check to see how fast the samples cool. Now just remembering that the samples are soil and water, are earth samples. Okay, we are at the 9-minute mark. Let's see. The soil is at 38 degrees. And the water is at 29 degrees. We have 1 more read, the 10-minute read, and the 10-minute read is going to be the same as my 0-minute in the shade. So I'm going to, whatever the 10-minute is going to be the 0 for the starting time for the soil and water. And then I'm going to quickly move to the shade so that we are as accurate as possible. Okay, looks like it's time. And the soil is at about 39 degrees. And the water is at 29 degrees. Okay, time has started again. And now we are going to check 10 minutes in the shade. We are at 28 seconds. Hopefully it'll be a little bit easier for you guys to be able to see the thermometers now that you're in the shade. I know it was not so easy in the sun. Okay, let's check. Our soil looks like it's at 35 degrees. And our water looks like it is at 29 degrees. Now remember, I just did the reading. This was the read for the 1 minute in the shade. Okay, we're gonna get ready to do our 2-minute read in the shade. And the soil has dropped even lower than 35, right? We are at, say, 34 for the soil. And the water is at 29. Now, if you live in an area where you don't have a sunny spot, you could use a bright lamp. That's another option. Okay, let's check it. Let's check our soil. Our soil is, wow, at 31 degrees. And our water is at 29 degrees. Okay, let's do our 4-minute read. Our soil is at 30 degrees and our water is at 29 degrees. Okay, let's do our 5-minute read. The soil is at 30 degrees and the water is at 29 degrees. Almost at our 6-minute, and we'll see the soil holding at 30 And the water is about 28, I would say. Okay, let's do our 7-minute. Still at 30. And the water is still at 28. For the 8 minutes, the soil is slightly below 30. I'm gonna say it's still 30. And the water is still at 28. Let's do our 9-minute. And our 9-minute, the soil, I would say it's still at 30. And the water is still at 28. And for our 10-minute in the shade, the soil is still at 30. And the water is maybe at 27. Now here are my results for the experiment. Please make sure to copy down these results. Unless you have your own data, then you may go ahead and use your own data. You can pause this video right now. Make sure you can copy it so that you can answer the questions below. Now, to calculate the change in temperature in each material, we saw that the soil heated by 18 degrees, it went from 21 degrees to 39 degrees. That's an overall change of 18 degrees in 10 minutes. And it cooled by 9 degrees in 10 minutes because it went from 39 degrees to 30 degrees. The water heated up by 6 degrees. It went from 23 degrees to 29 degrees. And it cooled only by 2 degrees in 10 minutes because it went from 29 degrees to 27 degrees. Now go ahead, answer questions 2 and 3, and 4 and 5 on the following page. Now, let's go over our results and our procedure as well. And let's discuss what we did and why we did it. Well, I had 2 samples. I had water and I had soil. And these are both called earth materials, right? Water is something you find on earth, and soil is also what the earth is made out of. You could have used sand or soil, either one would have been fine. We put thermometers inside of the samples, covered the lids to make sure that there were no outside forces affecting our temperature. And we took the temperature 10 minutes in the sun every minute, and then 10 minutes in the shade. Now, what did we notice? Is there one that heated up faster? The soil started off at 21 degrees, and it went all the way to 39 degrees. That's a difference of 18 degrees it heated up in 10 minutes. Now the water started off at 23 degrees, and only went to 29 degrees. That's a difference of 6 degrees. What about the cooling? Well, the cooling, the soil went from 39 degrees to 30 degrees. That means it cooled 9 degrees in 10 minutes, almost a degree a minute. And the water only cooled from 29 to 27, 2 degrees in 10 minutes. Now, if I were to ask you which earth material heats up faster, what would you say? It's the soil, for sure. If I asked you which one cools down faster, same, it's the soil. Now, what if I asked you which one heats up slower? Well, that's the water, and it also is the one that cools down slower. Now, why is that? Well, water is a heat sink. It's slow to heat up, and it's slow to cool down. It takes a long time for it to heat up, but once it heats up, it traps the heat in it. Think about it. On a hot day, if you went to the beach, it might be 10 o'clock, 11 o'clock, 12 o'clock, and if it's a really hot sunny day, you won't be able to step on the sand without your shoes. Your feet will burn. But going into the water will cool them right off. The water is not as hot as the sand. Now, talk about later in the day. Let's say 6 o'clock, 7 o'clock, 8 o'clock, where both the sand and the water have been in the sun all day. But if the sun is gone, have you felt the sand? It is no longer hot. It is cool. But the water is actually even hotter in the afternoon at 6 o'clock and 7 o'clock than it was at 12 o'clock when the sun was directly on it. It's been heating up all day, and once it's hot, it's going to cool down, but it's going to cool down much slower than the sand is. Now let's go back to my balloons. I had 2 balloons. One popped and the other one didn't. Well, one of them, the one that popped, was filled with air. So as the flame touched the rubber on the balloon, it heated it up and it made it pop really fast. Can you guess what was inside my other balloon? It was water. Now I had water inside my other balloon, and the water actually was not allowing this balloon to heat up as fast. It was absorbing the heat inside of it and allowing the balloon to stay intact. Now, if you try any of these at home, make sure there's an adult with you, and always make sure that you have the right protective gear.